The Geneva drive. It's used in basically everything that you use in your day-to-day lives. So watches and clocks, cameras and films, and also like CNC machines and other fabrication machines. But what actually is a Geneva drive? It's a mechanical stop-go converter, basically like a switch. It has one wheel that's continuously spinning, and on it has a pin, and the other one has a slot. So as it's rotating, the pin goes inside of the slot, and that is one revolution. So you can have it in different variations, where you can have 4, 6, 18, whatever amount that you want. And the amount that it goes in is dependent on the amount of slots. So if you have 4 slots on one, then it has a 75% dwell. If you have 6 slots, then it is an 83% dwell, and so on and so on. And that is just the amount of times per revolution the pin actually goes into the slot. And then the blocking disc presses against the pin and it stops it from moving until the next slot. So think about it like this. If you have a watch or a clock, and each time you have that ticking motion, it is the Geneva drive's pin entering one of the slots. And then you can control it and you can time it depending on how many slots there are. And that basic principle has helped to design basically everything that you use in a day-to-day life. The only problem is that the pin is actually a mechanical flaw. It's usually really flimsy, so it can break off, and if it's going at really fast speeds, then it can actually wear down very quickly. So what they use in actual Geneva drives or similar, they use a hardened steel for the pins, and they also machine the discs in a way where it reduces the frictional wear and tear of the actual drive. And of course, there are now modern replacements like stepper motors that are actually digital versions, which work the exact same way, but it's just digital and it's in electronic form as opposed to the mechanical switches such as the Geneva drive. To understand this in more detail, I'm going to design and print a model on Fusion, and then I will show you exactly how it works in real time. So I've got my Fusion open and I'm going to start designing the Geneva drive. So I'm going to start with a disc which will house the base plate, and I'm going to start with the star that has 4 slots. So the general principle behind this is that the base is going to have a circle with a pin on one of the rotating axes, and then the star is going to have the slots, but they're going to intersect at about a 45-degree angle, so that once it reaches a certain point, it will follow the arc directly into the shape of the circle. The wheel will continue spinning, which will bring it out, and then the cycle will continue. So this was taking me way longer than I actually expected, but I'm trying to get it perfect because most of my other designs, they've just been like quick designs and they haven't been that detailed. So what I want to do for this one is actually make it work. I want it to work how it was intended, and I want to make it work exactly how I envision it. I'm now going to try and make it perfect. So I've got the rough sketch on there. I've got my circles there, which is going to act as the main drive, and then I've got the star on the right side. That star is where the pins are going to drive into, and as you can see, I've got that small circle, 4mm, and that is what's going to actually go inside of the slots. So what I need to do now is mirror that half of the star, and that will give me the full shape. But that's going to leave them as 2 separate pieces. So what I want to do is make a base plate of sorts. So I will have a base plate that will actually connect them, will allow for free spinning of the components, and will still allow them to remain together. That way it's easy to spin and easy to demonstrate, and you can still see its full motion. So that's what I'm going to design separately right now. This took way longer than it should have, but now I am done. It is looking quite messy so far, but that's literally just a sketch. I just need to start extruding them and then making them different bodies, and then I'll be done with it. So I've got the base plate, I've got the circle, and I've got the star. The only problem is I'm not sure how well that star is going to rotate, but we'll see how it works because of that section over there and over there. And the problem with that is that they're not exactly the same height, and I couldn't figure out how to make them the same height while keeping the radius the same. So I will see if it works, and if not, I will just adjust it and reprint, but I shall see. Okay, so now I'm done with my design, and I've separated it into 3 different bodies. I've got the main body, which is the base plate, and then I have the body for the driver or that circular disc, and then I have a body for the star. So I'm going to print them separately. It's not going to need any supports, thankfully, and then I should just be able to get it done. It's a really simple design. It's just got the 3 discs, the 2 discs, and the base plate, and then it's got this slight lip to separate them, and it's got these extrusions. That's the pin that's going to go inside of the slots, and then it's got this part over here and this part over there. What those do is just gives a little bit of a guiding hole for the other body. So you can see that one won't move around because it's now got a slot that aligns with it, and this one has the same thing over there. So they will just be able to rotate as you turn that part, and hopefully, if all goes well, then that slot should be able to go between the rest of them. So I'm just going to put it on the build plate now. I'm just going to export all of the bodies, and I'm going to put them onto Bambu Studio. So I've got the first one exported there, and then the second one and the third one done. So now I'm going to open up Bambu Studio, and I'm going to go onto the prepare page, sync the information because I use my printer as well on my laptop. So I'm just going to sync all of the information, and then I'm going to just set this to print. Alright, so I've now got everything on the build plate. I've changed my speed settings to these ones over here, and I've changed my support so that this one has a slight brim, and then everything else I kept basically the same. So I can send it over to the print plate. It's going to take an hour and a half, and it's going to use 35 grams of filament, and then I can just wait for that to be done, and yeah, I can just test it out. So I just got finished with the print, but I completely forgot to regard one thing. So the print is finished over here, but if you look at this rotates completely fine, but I forgot to make the base spin. So even though that's rotating, it's not rotating anything along with it. So that's not rotating because it can't. So I just put a design back on the print plate, and hopefully it should work now. Okay, so I made a few small design changes to the thing, and what I did was I changed the depth of the slots. I also cut the circle part in the middle in half, so now it's a semicircle, and I increased the height of one of the pins. That way, the slots could actually go in, and the thing could fully rotate each time, and you could see the movement more clearly. So I got that off the print plate just a few minutes ago, and I tested it out, and it's working perfectly fine now. You can see the full motion over here, where if you rotate it, the pin slots into there, rotates it again, slots in, rotates it again, and then it keeps on going in a circle. And that's what it means by it only works some of the times. It's working basically as like a frame rate in the camera. It gets inside, and then it spins, and then it has a bit of a lag, and then the next frame, and then it spins, and then it has another lag, and then the next frame, and so on and so on. So if you wanted to increase the amount of slots for this, you would just have to change the amount of slots, and that will give you a different ratio. So if you added 6 slots, it would be 83%. If you added more and more slots, then the amount would increase. So that's basically just the whole principle of this. Overall, I think that it turned out really, really nicely, and if you want to see any more science and 3D printing explanations, then check out that video over there.